Good morning, my dear students. In today's class, I am going to discuss about how to provide isolation between transmitter and receiver. Already we know that from the CW radar block diagram, only single antenna is used for transmission and reception. Single antenna is used for transmission and reception. The transmitted signal is a very high power signal in the megawatts power, but the received echo signal power is very small. It is in the milliwatts. The transmitted signal in megawatts, the received signal is in the milliwatts. Suppose by mistake, if the transmitted signal will enter into the receiver, the entire receiver will be damaged. So that we have to take a precautionary steps to provide isolation between transmitter and receiver. Already we know that the transmitted signal frequency is f0 and the received signal frequency is f0 plus or minus fd. The transmitted signal frequency is different and received signal frequency is different. Based on this, we can provide the isolation, that is by using Doppler effect. And second, by using a magic tees, circulators and hybrid junctions, we can provide the isolation. By using microwave devices, circulators, hybrid junctions, we can provide the isolation between the transmitter and receiver. And by using separate polarizations, for transmission one polarization and receiving one polarization, by using separate polarizations also we can provide the isolation between transmitter and receiver. And the largest isolation is provided by using separate antennas. For transmission one antenna is used and for receiving another antenna is used, so that there is a maximum isolation between transmitter and receiver can be possible. And if the transmitter leakage power, amount of transmitter leakage power will be tolerated by the receiver will depend upon the capability of the receiver circuitry to withstand the power. And the second one is the transmitter noise entering into the receiver from the transmitter. On these two parameters, we have to provide isolation between transmitter and receiver. The amount of isolation depend upon the amount of power that is tolerated by the receiver circuitry and amount of noise that is entering from the transmitter into the receiver. Based on this, we have to provide isolation. The isolation can be provided by using a Doppler effect, by using the circulators and hybrid junctions and separate polarizations, and by using separate antennas, one for transmission, other for reception, you can provide the largest isolation. This is about isolation between transmitter and receiver. And the next concept is non-zero IF receiver. In normal CW radar, we studied previously, in that the intermediate frequency is 0, that is a zero IF receiver. The intermediate frequency is 0. It leads to a sum when the intermediate frequency is 0, the effect of flicker noise will be high, and the operated frequencies are low, then the effect of flicker noise is high. To overcome this, we are going for the non-zero IF receiver. In this, the intermediate frequency is not 0, it having some value, some high value. If the intermediate frequency is high, the flicker noise will be reduced. The flicker noise normally occurs in the second detectors and envelope detectors, all in the semiconductor devices, and the flicker noise varies inversely proportional to the frequency. The flicker noise is proportional to 1 by f. If the frequency is high, the flicker noise is low. So that we are going to use high intermediate frequency, so that the effect of flicker noise is reduced. That is the advantage of non-zero IF receiver. The effect of flicker noise is reduced because of high intermediate frequency. We can see the block diagram now. Here also CW transmitter is there. It generates a continuous signal with a frequency of f0, and the received signal frequency is f0 plus or minus fd. Here in this non-zero IF receiver, separate antennas are used, one for transmission, other for reception. Therefore, largest isolations are provided between the transmitter and receiver. And then the local oscillator signal in the receiver is provided from the transmitted signal frequency f0 and local oscillator frequency FIF. The transmitted signal frequency f0 and local oscillator frequency FIF is given to the mixer. The mixer will generate original frequencies and sum of frequencies and difference of frequencies. That means it will generate f0, f0 plus FIF, f0 minus FIF, and a lot of frequencies it will generate. And only one frequency is selected by using a sideband filter. The sideband filter only select one frequency, that is f0 plus FIF. That means the local oscillator for the receiver is derived from the transmitter frequency and local oscillator frequency, and for the receiver mixer the frequencies are f0 plus or minus fd and another input is f0 plus FIF. The mixer will generate the difference frequency, so that f0 and the mixer will generate a difference frequency, so that f0 and f0 get cancelled. Remaining thing is FIF plus or minus fd. Here we have two frequencies, FIF plus or minus, we have two frequencies, FIF plus or minus FD. FIF is the intermediate frequency. It is a high frequency. If the frequency is high, the effect of flicker noise is low. And the remaining blocks already we know. IF amplifier, it will allows only intermediate frequency. Intermediate frequency, and the frequencies around the intermediate frequency. The second detector will discard the high frequency term or carrier frequency term, so that FIF is eliminated. Only FD is occurs from the second detector. The second detector will eliminate the high carrier frequencies, and FIF is eliminated. Only low frequency FD is occurs at the output of the second detector. And next we have a Doppler amplifier. Already we know the application or the use of Doppler amplifier. It eliminates echoes from the stationary targets, and it also amplifies the Doppler signal to the level of the indicator. The indicator in the CW radar, the indicator may be a frequency meter, or maybe earphones can be act as a indicator. This is about non-zero IF receiver. In the non-zero IF receiver, the intermediate frequency is a non-zero value, and intermediate frequency is a high value, so that the effect of flicker noise is reduced, and separate antennas for used for the transmission and reception. One antenna is used for the transmission, and other antenna is used for reception. The separate antenna is used for transmission and reception. Therefore, largest isolation is provided. And this is about non-zero IF receiver. This is a very important concept. It is asked many times in the university examinations. And thank you very much.